Welcome to my YouTube channel Science Innovative Brain. So guys, today's video lecture I am going to explain about how you can select the gate turn on turn off resistance of your IGBT or MOSFET. If you are facing a problem in your gate driver pulse waveform, then you can solve that problem by using this video lecture. Also, if you want to increase the power electronics knowledge, then you watch the video till end. So guys, welcome to IGBT gate turn on turn off resistor selection guide. So here we will discuss how we can select this RG value. RG is only called as a gate turn on turn off resistance, and this is called gate driver. This is your IGBT. So first we will discuss what is gate resistor. So in the gate resistor we will discuss, but before that we will understand why we choose the gate resistor. So if you see here, this part is called as a gate driver. So this is only driver circuitry which will generate the PWM pulses, and this part is called as your IGBT or MOSFET section, which we want to make it turn it on or turn it off. And between these two we will connect one resistor or one pair of resistor, that is called gate resistor. This only we have to select it properly. And this part also divided into two parts, which is first part is called gate turn on resistor and second part is called gate turn off resistor. So this part is gate turn on and this part is gate turn off resistor. This turn on is responsible to turn on this IGBT, and this turn off resistor is responsible to turn off this IGBT. The effect of gate resistor we will discuss first. So if you not choose the gate resistor proper, if you not choose this gate resistor proper, you will find the spike or some another problem in the waveform, which you can measure at this point. This point you can measure it. If you select high resistance value, what will happen? You will find the rise time of the PWM pulse is too much and the fall time also will get more only. Like this you will get. At that time, if any other complementary pulse will come and it will start from here, then your IGBT can damage at this point, because both IGBT are turned on if it is a half bridge or H bridge configuration. So you have to select this resistance, should not select this resistance too much high and should not select this resistance too much low. If you make the resistance 0, what will happen? Your rise time will increase, but you will find one spike here like this and some of the oscillation. Then your pulse will come, and then fall time also like this sharp only you will get, but it will go some under spike and some of the oscillation, and then it will go like this. So we have to select proper gate resistance. Here I have done some practical and I found that here the effect of the gate resistance I am showing here to practically how I got this result. What I did, I made turn on resistor to 0 value. So what will happen here, if you see, when I made the turn on resistance to 0, sharp time rise time is very sharp, but I got one spike here. If you see here, this is the spike. What will happen? You made the some, see if you see here 1, 5, 10, 15, then it become 13. So it will go sometime, maybe it will go out of the range of the gate potential, so your IGBT can damage also here. So this spike I don't want. And another case, that gate resistance I choose higher only, so what happen, this fall time become okay only. And but here also it is not optimized, so it is not going perfect zero, little bit curve is there, little bit fall time increase because of this curve. But in second case, I may turn on resistance higher and turn off resistance 0. So in this case, if you see the rise time become little bit more only, and here curve found. But fall time becomes sharp, and if you see here, I got one negative spike. So negative, if you see the negative voltage 5 volt, 10 volt, then more than 10 volt. Here 12, approximately 12 volts back side it is coming, negative side it is coming. So here also one ringing is coming. So this problem is coming when I made the resistance value turn off resistor is 0. But if I am making both resistance little bit high above the 0 value and above the optimized value also, then what will happen here, if you see same resistance, because of the, as per previous case, this case, the rise time is more and fall time also more, but both are approximately optimized this pulse shape. But if you make little bit, this resistance is lesser than this whatever I have selected here, then this resistance also if you make lesser, so you will get this type of the rise time, here fall time. But I don't want this section, so we have to remove this. So and we have to remove this, and I want the rise time like this and fall time like this, then only my selection of gate resistance is optimized. So how we can select the right gate resistance, question is coming here. So we'll discuss this thing. So before selecting the gate resistance, I have drawn the actual model of the your gate driver and capacitance of the IGBT. So if you see here, this part is the gate driver, this CG is the capacitance which is equivalent of the input capacitance of the IGBT, and this RG is turn on resistance and RG off is turn off resistance. L is representing here in stray inductance which is coming by connecting wire, because gate driver is connected to the IGBT with the help of some of the wire. That wire is producing some of the inductance, and that inductance is equivalent value is represented here. If you see the equivalent circuit diagram of this section, this is called RLC. This section, this is RLC. So RLC network. So this is RLC network, and if you see the second order expression of this RLC network, you can find this equation. By solving this second order differential equation, we can get the turn on resistance RG value, because this LG we know and CGG also will know by the data sheet of the IGBT. So we want a non-oscillating equation to optimize the gate resistance, because previously I told this, if you choose the oscillating means oscillation will happen and you will get some of the oscillation. So if you not choose the properly, what will happen, this type of the oscillation will come in the input waveform and this type of the output. So I don't want, so damping condition we have to fulfill. So for the non-oscillating solution, here if you see non-oscillating solution condition is this one only. This equation we have to follow to select the correct value of the gate turn on or turn off resistor. and the minimum value is this one, equal value, and this is greater than equal value, this value. And you should not choose the more value also. You have to optimize. If you choose the more value, what will happen? You will get rise time like this and fall time like this. When the complementary pulse, if you see here, this point is the dead time is approximately 1 microsecond if you give in. So another pulse will start from here and going like this, and this point, at this point your IGBT, both IGBT will turn on, and that time is not followed, and your IGBT will damage if it is a half bridge or H bridge configuration. So I hope that with the help of this equation you can find out the correct value of the resistor. So thank you. If you like this video lecture, please share it, subscribe it if you are the new on the channel, and share to your friends also, your children's also, and your colleagues also, so that they can increase their knowledge in the power electronics field. Thank you. Bye bye.